All right, so here's what's happening. I added an extra day in the calendar last year because I felt, chapter 3 is huge, and it never goes away. Kids were like emailing me over the weekend, says the test just on 3.7, 8, and 9. No, it's gonna be on everything, because I can't really ask questions without power rule in it. Product rule will always happen now. So these things, they all gonna be up on your face forevermore. Chapter 4 is applications of derivatives. So when we find the derivative, what does it mean that the first derivative is negative and the second derivative is positive? What does that look like on a graph? So derivatives never go away. I can't give it a name yet because the student's still in the school. Usually my rules, like the Jonah rule, the Ellie rule, first of all, they've long left the building, but they're usually for something positive. This one particular student chose to not learn derivatives till January. It made chapter 4 and 5 really hard. So chapter 5 is integration, which, by the way, integration is just undoing derivatives, and sometimes it's, well, I know what that guy's derivative is, so when I see that, I know it's integral. Orange in particular. This symbol means integrate. Whose derivative is that? Not tangent, but arctan. So, ta-da, you just integrated. And then there's a little plus C thing that we'll talk about later. But that's the integral. How do you do that integral is you just know the pattern. So if you don't know, like if derivatives aren't clicking for you right now, we need to get better at it. So that said, today is to go over anything from implicit differentiation and trig inverse derivatives. Monday, I will show you how we do the derivatives of those guys. And Tuesday is a fairly short thing on how to do derivatives of a moving target to a moving target. Those kinds of questions aren't usually on the AP exam, but it's a technique that we're going to use and need in chapters 7, 8, and 9. So we're going to start practicing with it now. And then, so Tuesday and Wednesday, Tuesday's a little bit of stuff. Wednesday is review for whatever you want to talk about with chapter 3, and then Thursday's the test. But these problems from a few days ago, questions, 45 is always asked. So we will at least do 45. Because it's fun. Someone who got it? Anybody want to put the problem up? There's some of you that I know that have done it and you're looking away. Yeah? Woohoo, yay! So of that, velocity is v equals 8 times the square root of s minus t plus 1. I have v, s, and t. Are they all changing? Are they all variable? Is anything a constant in there?
Like 2 or 3.
What?
There's like 2 constants there.
S and t are constants?
No.
Oh, the 8 and the 1. Okay, they don't have letters. So everything with a letter is moving, right? So d what? Sorry, dt. Okay, so we're doing the derivative of all of these variables with respect to time. So she multiplied by the power. So 8 times a half is 4. And her sleeve and her book keep hitting the board, so she's not being messy.
Sorry.
She's not being messy, it's the board's being sensitive. So multiply by the power, lower the power. And then she's gotta do the derivative of the stuff inside,
So,
which is ds dt minus 1, and then the derivative of that plus 1 went away.
so this ends up being like this.
Ah, and now she's pointing out the trick. The thing where, because usually you guys can do that first step, and it's big and it's yucky. Yeah, welcome to my world. The board is possessed and super slow.
Okay.
There,
Okay.
now you got to put it back on pen, or you're gonna. See, this is my way of getting sympathy from you guys. Working on the board is just horrendous. Okay, but she did the derivative of s with respect to t. Well, that is, how is the position changing as time is changing? Most of us call that velocity. And she's saying that ds dt can be replaced. With what? With the velocity equation that it gave us in the problem.
So the minus and the plus ends up canceling out. And then this also cancels out because it's in the bottom. So these two cancel out, and you end up with 8 times 4, which is 32
Okay,
per second.
so that might be too much canceling for them to fully
Yeah,
catch.
sorry.
Okay. Come on, board, you can do it. There we go. Ooh, oh. So again, the derivative of this multiplied by the power, lower the power. And the derivative of 1 goes away. And then she did, right here, the derivative of the stuff inside. How is s changing with respect to time? Minus 1. And then she took all of this and plugged it in. And said this is all 8 square root of s minus t plus 1, then that minus 1. And that's what she's saying is those guys cancel, those square roots cancel, and I get 32. Okay? And really the catch was understanding what ds dt was. That you did have an equation for that, they just called it something different. Other questions from this day of implicit differentiation? Nothing? Okay. Anything from trig inverse? Okay. Then can you guys show me how to do 9? And Evelyn, if you want to like move up to one of the groups that only has 2, you don't have to be all by yourself. Constantine, can you do the first step for us on the board? Whatever that means.
What do you mean by the first step?
Well, there's probably some cleanup needed, but so apply the pattern of secant inverse. Oh, that's not a square, that's a comma in the problem. So that changes things. Let's see, how can we do this easily? There we go. It's close. It's missing one little thing. What's he missing?
You have to just, like, within the square root, I think, t, it's squared, so like it's 1/t squared.
Oh, yeah.
Yep. So secant sucks. It's got the jail bar stuff. Begins with an S, so there's a square root, a squared, and a subtract. And then he correctly did the derivative of the stuff inside, the derivative of 1/t multiplied by the power, lower the power. And I like the way he wrote it. He didn't write -1/t squared on the top. He just said, I'm multiplying the whole thing by -1/t squared. Perfect. And I claim that I don't need the absolute value bars. Why?
Because you included the range from 0 to 1.
Well, the book of restricted the range. Okay, so this becomes -1 t squared times 1/t and this is not the answer that's in the book. And students usually ask, well, how do you make my right answer look like theirs? Because this is correct. And a lot of the AP exam, half of it is multiple choice. So you need to be able to be creative and take your brilliance and make it look like their brilliance. Am I allowed to do that? I squared the number and square rooted it all at once.
Because of the restriction, yes.
Because of the restriction, yes. If it was potentially negative, then I've created things where -1 equals 1. Because when I square them, that's true. But this, it said it's only positive, so we're good. Okay. And with square roots, what is the square root of 2 times the square root of 3? Root 6. So I can do inside times inside and leave it inside. Okay. So I'm going to kind of distribute that in there. T squared times 1/t squared. And you're done. Here's another thing that you would have never done before, but now that things are so complicated, sometimes you guys like to do this. That's not true. You cannot do that. Please don't.
What if you make it like 1/cosine t? Does that work? Or cosine inverse t?
Okay. So secant of what equals 1/t and this is the t and that's 1. So it's not so is it asking cosine inverse of t or 1/t? Like,
I don't know, I did it with 1/cosine inverse t, and it works.
Right, so it's that this inside also turns upside down, and did you know to do that, or were you lucky?
I thought to do it.
You
'cause,
thought
like,
to do it,
If you
yeah.
flipped it.
Okay, that should work as well. Other issues with any of these guys? Sam? Ben? Me? Sorry. Okay. Hold on. So, the copiers were possessed this morning, so I did not get this printed for you, but I'd like you guys to try. It will very slowly come up. Okay, so first, let's just look at the first question. This is a circuit training sheet, and the way those work, again, is this one's number one, and they're asking if this is K, find K prime. So, in terms of X, Evelyn, what is K prime of X? Just in symbols.
Prime of f of x plus prime of g of x.
Okay. Oops. And now K prime of 1 is F prime of 1 plus G prime of 1. So Team Milo. This Milo, then that Milo. What is F prime of 1?
Negative 8.
Negative 8. Just pulling it out of the table. G prime of 1.
3.
3. So we get negative 5. And then, to find the next question that we're looking for, we gotta find which answer says 5 on it, and down here. And you guys still need this information. So try solving that question. And I'll see if I can use it.
Like, no, it makes sense to me, and then I'll just answer the table
Hand them around. What do you get?
4.
4? Because it is half of f prime plus 2 g prime, and then evaluating at 2. Okay, so the questions are coming around on a sheet, and what you don't have is how to find their derivatives. So the answer of 4 isn't written on any of these guys, so we need to look on the back. And the next question to answer is on the middle and the back. Yeah?
Oh,
We're one short.
Okay. I have more coming, so I will go get more.
no, it's fine, you can have it.
But the sheet that I did not copy is the one that tells you about these guys. I'll go get yours.
That's the last one we got. No, but like,
Right now.
yeah.
You can leave them fixed. Paddlers.
Did you rate the test?
I graded half of them. So I graded all of one version. So I have half of them in every class done. And if your half was the one that was graded, the scores are in. And I just wrote a question that's not on there, but where am I not allowed to evaluate the derivative of g of x times j of x? X equals 2, why?
I forgot this was negative, yeah, it's just negative.
I don't disagree with you, but why?
Because those are corners?
Okay, because doing the derivative of that product, I'm gonna need the derivative of g prime of x, or sorry, g prime of x, which is defined at 1. He's saying at j of 2, what is the derivative of j at x equals 2? I don't know. It's a corner, so you can't do the derivative there. Just check it. Are these feeling reasonable, though, what you've seen so far, the problems? Okay. And you have no official homework tonight? Yeah. Kind of recommend looking at the sample test online, but there's a number of things on there that we haven't done yet.